All right, class, this is example 2. I'll start off by getting the critical value. Again, it's numeric solver. So in this case, we have degrees of freedom. So we have 2 rows, okay, and we have 1, 2, 3, 4, 5 columns. So to find degrees of freedom, you take the number of rows minus 1, so 2 minus 1 is 1, times the number of columns, we have 5, minus 1, so 4. So our degrees of freedom is 4. For example, this is example 1, but for example 2, it says we have an alpha. We're going to use that's why I have the information from example 1 up. But for example 2, it says our alpha value is 0.01. So here's how to find the critical value, chi-squared, all that stuff we've been doing. We're going to solve that. Surprise, surprise, we get the exact same thing we got in previous problems. So 13.277 is our critical value. So that's the number we're going to compare our test statistic to. Okay, so HO says that these two, being male or female, these numbers are exactly the same. HA says it changes if you're male or female, meaning that males might like a cup more than females, and so on. Okay, so that's what we're trying to determine. So what you're going to do is when you get to these problems, you're going to put the data that you observe, and this is the data we observe, into matrix 1. Okay, so we're going to use matrices for these problems. So you go to matrix 1, or matrix A, I guess, edit, and this matrix is a 2 rows by 5 columns. So I'm going to go 2 by 5, and then I'm going to enter in all this data. So 592, enter, 300. So if you don't want to watch me enter all this, go ahead and fast forward. Or you can just ponder your life a little bit. Just see where you're at in life as you enter this stuff. Hopefully you're all in a good place, right? We're all still hanging in there. All right, so now it's all entered. Okay, this is our observed matrix. Now we want to get our expected matrix, and that's going to go into B. It doesn't matter what you put them into, just as long as you know where you put them into. Most of these problems just have it as A and B. Okay, so how do we get the expected? In order to get the expected, you got to start with the observed, and you have to add up these two numbers. And the book already did that for us, but when you get to the online problems, you have to do that on your own, and then write these numbers down somewhere, so they're really handy. Okay, so you have to add up this column, get this number, add up this column, get this number, add up this one, and so on. Add up your whole row, get this number, add up your whole row, get this number, and then add up these two. This is your total number of samples. Okay, so to find this spot up here, this very top left, this one right here, I'm going to take the total here times the total here divided by this number. So 1002 times 1200 divided by 2200. Okay, and we get 546.55. That's the number we actually should expect. If these are independent, we should expect 546. We got 592 for that spot, so we're not too far off. Okay, so to get this spot, same pattern, 635 times 1200. And divide that by 2200. And enter, and then the next one. So 384 times 1200. Divide that by the total, and then go to the next spot, 44. Divide that by the total, 135. Okay, and then go down to the next column. Whoops. They're mowing the lawn at the school, so it's a little distracting for you, I'm sure. I'm going to just plug right along here. 635 times, so I'm using, for this spot right here, it's 635 times 1,000 divided by the total. 384 times 1,000 divided by the total. 44. There we go. Okay, so this is our expected matrix. I'm going to quit out of that. Okay, so we already have our test statistics. It was like 13.277, correct? So now to get our, wait, hold on. We found our critical value. Critical value. Now to get our test statistics. So now we're going to go to stat, tests. And this time we're going to use just the chi-squared test. This is the independence of variables. Okay, we have our observed in A, our expected in B. B can have decimals, A cannot. Hit calculate. We got a really small p-value. We got a really high chi value. So this number, 23, is bigger than our value of 13.277, if you can remember back to when we started this video. Also, you can see our p-value is extremely small. It's less than our alpha value. So these are two ways you can tell if we're going to reject HO. We are absolutely going to reject HO, meaning that male and female, according to our study, like these 5 things differently. Okay, looks like males like this more. Can't tell. Obviously, females like the cones more here, according to our study. Okay, so that is how to do example 2, and those same problems you're going to see online.